This is a continuation from the previous video. We're told that adult male pulse rate are normally distributed with a mean pulse rate of 69.58 beats per minute and a standard deviation of 11.33 beats per minute. So again, my advice to you is anytime that you know that you have data or a random variable that's normally distributed, make a sketch of a bell-shaped curve for data that are normally distributed. Mark or label the center of the distribution with the mean value, which here that's 69.58 beats per minute. And this picture will help you answer any questions dealing with proportions or probabilities. Okay, in this problem, we want to know what proportion of adult males have normal resting heart rates if a normal resting heart rate for an adult male is between 60 and 100 beats per minute. So, uh, real quickly, another word for proportion, you can substitute that word with percentage. So you can think of this question as what percentage of adult male pulse rates are between 60 and 100 beats per minute? Or you can also think of the proportion as the shaded area under that bell-shaped curve. Okay, so let's go ahead and mark where 60 and 100 are on this bell-shaped curve. And it doesn't have to be to scale, but we know that 60 is below the mean value and 100 is above the mean value. So once you have those values marked, the next thing that you want to do is you want to shade in the area between 60 and 100 beats per minute. And the area that we're shading in red here represents all the male pulse rates that are between 60 and 100 beats per minute. So we want to know what the area of this red shaded region is. And once we figure out what this area is, it's going to correspond to the probability of pulse rates that are between 60 and 100. In other words, I'm going to write off to the side here. What we are trying to solve for is we want to know what is the probability that X is greater than 60 but less than 100. So in this video, I'm going to show you how to find this area by using z-scores and the z-table, which we're calling table A2 from the appendix. So remember that the formula for calculating a z-score is z is equal to x minus mu over sigma. And it's a good idea to memorize this formula if you haven't already. And so the first thing that we're going to do using the z-table is we have to take the pulse rate of 60 and figure out what its z-score is. So I'm going to write just right below it in blue. Let's call that z-score for a pulse rate of 60, z sub 1. And then we're going to calculate the z-score for a pulse rate of 100. So we'll just call that z sub 2. So we need to figure out what those guys are. So let's start with z sub 1. What's the z-score for a pulse rate that is 60? So to calculate this, that's 60 minus the mean value divided by the standard deviation. Stick that into your calculator, and we should expect a negative z-score, which it is, negative 0.85, because 60 is on the left side of the mean value. Now let's go ahead and do the same thing to find the z-score for a pulse rate of 100. So that calculation is 100 minus the mean pulse rate divided by the standard deviation. And because 100 is on the right-hand side, we expect this to be a positive z-score, which it is. It's 2.68. And then now that you have the z-score, we can use the table to look for the area. Now remember that the table gives you the area that's to the left of each z-score. So I do not have a screenshot here of the negative z-scores, but you can pull out the negative side of the z-score, and I'm going to use a different color here. So I'll use, let me see here, I'll use green. So let me use green here to find the z-score that corresponds to an area of negative 0.85. So from your z-table on the negative side, you will see that that z-score corresponds to an area of 0.1977 to the left. So I'm going to go ahead and draw that on the distribution and shade that area in green. Okay, so the area to the left of 60 beats per minute, or the area to the left of a z-score of negative 0.85, is an area of 0.1977. Okay, let me see if I can choose another color. I'll use blue, okay, to shade in the area that's to the left of a z-score of 2.68. So that's the area to the left of a pulse rate of 100. So I do have a screenshot of that table on the right. So this is the positive z-scores. So I'm going to go down, search for 2.6, and go to the column that's 0.08. So we can see here that the area that's to the left of a z-score of 2.68 is an area of 0.9963. So I'm going to shade that. And if you can follow along with me here, the area that I'm shading in blue covers the area that's in green as well as the area that is in red. So that entire area in blue has an area that corresponds to 0.9963. Okay, but I need the area that's just in red. So the area that is between 60 and 100. So how do we do that mathematically? We just need to do some subtraction. So let me get my pen here, right? The area or the probability that is between 60 and 100, we have to take the area that is in blue, which is 0.9963, and subtract the area that is in green, which is 0.1977, and hopefully you'll see that what's left is the area that is in red. So if we do that calculation, that gives us 0.799, or approximately 79.9% of male pulse rates is going to be between 60 and 100 beats per minute. Watch the next video to see how you do this on the calculator.